Okay, I think we should get started.
Okay.
Yeah?
Sounds good.
So, yeah, so welcome everybody. Can you hear me well? Okay. Yeah, before we start, I would like to give a special thanks to Don and his team to make this happen. This is our next chapter in our engagement with Stanford, and very excited to present here. And yeah, welcome everybody. So today's topic is, yeah, the mic is not supposed to work. It's just for recording.
Yeah. The mic is for the people who are listening online through Zoom. However, if you have any trouble hearing from the front, please let us know.
Yeah, just let me know, or you can actually.
There's an open door in the back.
Or you can move to the front.
Yeah.
Yeah. So today's topic is really broad and wide. It's a tooling for machine learning, Amazon Web Services products, open source tools, and DevOps best practices. So thank you so much for replying with the comments and notes when you registered for this event. We've read through this notes and comments, and actually it's they are very diverse, from the very basic asks and curiosity about the machine learning in general to the very specific questions about natural language processing and all that stuff. We will try to keep the balance between everybody, and bear with us if you particular topics are pretty well known for you, or you just don't understand anything. We can follow up on any slide we will present today, and we are here for the next hour, I guess, and even later. So we can double click, triple click on every slide and elaborate more. 1 second. Why it's not? Okay. Yeah. So we're Squadex. We're consulting firm. Our main focus in machine learning, big data engineering, and DevOps, and especially in a convergence of those three disciplines, because in order to do a machine learning, you need a big data. To do a data right, you need a DevOps infrastructure and process around this. So, and we are Amazon Advanced Consulting Partner. I hope we'll get to premier level, maybe this year, maybe early next year. And I would like to note Chaitanya here in this room is Amazon Solution Architect from machine learning team. Please welcome him as well. Today's talk is going to be split between three of us. My name is Stepan, and there are two folks more, Iskandar and Rinat. Please meet them as well. We don't have titles in our team, but just I'm more a platform guy, and my colleagues are more machine learning guys. So you can treat it as well. So the way we want to structurize this talk is go through this machine learning workflow. This slide is copied from Amazon machine learning training materials, but it illustrates really well the overall process to give you a big picture. And yeah, of course, everything starts with a business problem and machine learning problem framing. But actually, the topics we will be covering today is about the data collection, data integration, basically the data platform, establishing the right data platform. Then moving to a machine learning steps like feature engineering, training, hyperparameter tuning, model evaluation, and each of those topics will be covered with tools available in Amazon ecosystem or in open source world, their benefits, limitations, and so on, and best practices here. Yeah, and the last step is model deployment and monitoring. So let's get started. As I mentioned, the data, you will not be able to do any kind of machine learning without data. So the first step is to ingest and collect your data. This is a very short tip. Do streaming as much as possible. This is like streaming is not a buzzword. It's a real thing that can help you to deal with your data pipeline. So a couple of reasons, like you probably know it, if you can think that 99% of world data has a timestamp. Probably just geodata or genomic data doesn't, it's static, yeah? But all the changes in the databases, all the write-ahead log, we have like a global write-ahead log, is something that is being changed constantly. And the most interesting insights, the most interesting machine learning stuff is gonna be done on a time series data. And you should do streaming. You should design your data pipelines in streaming way, even if you are not in real time. Then fast data is better than big data. You should process the data before it lands into your file system. Yeah, there is even like an interesting observation. If you don't process the data right now, you will never process it again, because it's in a big data, in a scale, it's really hard to process that data that is behind your current timestamp. Actually, streams is you can treat it as like advanced, more sophisticated and file system with a higher level of abstraction. This is you shouldn't be afraid of it. It's the same files but with a richer API to work with. It's a monitoring and operations friendly. If your batch job has, like daily batch job has failed, you will know about that just after it failed. If your streaming has failed just right now, everybody is going to be aware in the company. And it's going to be fixed much quicker rather than waiting for the next day before the reports particular reports are not going to be arrived to the business. Yeah, this is like the reference architecture pattern we see all the like in many projects that we participate on. I would like to share this like a architecture diagram. Don't like be afraid of this as well. I will not go into details, but this is like a streaming data platform that powers a data lake and has capabilities of provides the capabilities for developing microservices on top of the streaming data. We will be launching this in Amazon Solution Space pretty soon, just because this is a reference pattern and a well-architectured approach that we see over and over again, that helps to converge like a batch approach, streaming approach, and join all the developments in the microservice, all the best practices and benefits from the microservices world. So, and actually it powers the machine learning pipelines as well. The same version of this diagram, but with Amazon components replaced with an open source alternative, with Kafka Connect, with Kafka and Presto instead of Athena. Yeah, and a couple of more alterations with enablement of with data governance and SLAs and Amazon best practices around security and Again, so it's not like the main topic of this talk. I just wanted to give you an overview of that, how the data platform may look like, because it's like a really fundamental thing to power your machine learning projects. In my opinion, in my personal opinion, it doesn't make sense to even to start your machine learning initiatives like in an enterprise scale without having the foundation in place in terms of the data governance, data security, and data pipelines. So however, this is like I showed you an ideal world. Yep. However, in our practice, most of the teams, most of the companies start with a simple batch approach, and to get the like quick results in a pretty easy way. So you probably know the Airflow. Let's meet a little bit each other. Can you raise your hand who knows what Airflow is? Okay. So what is an Airflow? Airflow is a direct acyclic graph runner. It's an open source project from Airbnb. It's quite popular. What it is designed for is to process the data in batch, task by task, job by job. You have your source data, you have to take it out, transform, extract, load somewhere, then do further transformation. So the DAX might be as complex as you can imagine. It has a nice UI. It's basically like very popular, easy to start. A lot of plugins. You can plugins. That means like you can pull data from everywhere and store it to anywhere. It has some like limitations and concerns. Very fundamental architecture concerns like Celery. Celery is a Python framework for queue management and scheduling of the jobs. So basically, as far as Airflow is a DAG scheduler, it schedules jobs somewhere using a queue manager. And in fact, it's very unstable. It's not operations friendly. In most of the cases, it requires heavy lifting from the ops team, from IT department to make it work in the right way, and still has like a lot of issues. And just a tip for. I got you're not familiar with Airflow, but this is a direction if you will go and learn about this. Just use a Docker or Kube operators from the day one. Don't use a standard. In Airflow terminology, operator is basically the task which defines the transformation, not the transform, which defines a particular. An operator is a keyword to define the job to be done with any job to be done. So it's a very generic, very abstract DAG runner. So the job might be a Python job, or it might run just a Docker container with a particular like parameters or arguments to be passed in. The reason I'm mentioning Docker or Kube operators is to decouple the jobs itself from the Airflow DAG runner. So you will still have a nice UI, nice diagrams, nice DAGs, but you will be able to switch from unstable salaries, from unstable internals of the Airflow to something better. For example, to Amazon step functions. Yeah. Amazon step functions. Have everybody heard about this? Okay. The easy way to explain what step functions are, basically, it's a simplified way to run a particular tasks one by one, or in a particular order, on an Amazon environment, and a nice DSL for describing this sequence of tasks. This is also very generic, could be used for any type of business applications or whatever, but it's also can be used for data pipelines. So if you wanna pull the data from somewhere, transform it, and load it to another system, to your S3 bucket, for example, it's basically three functions to be defined in a Amazon Step Functions framework. Yeah, it's managed by AWS. Very, of course, highly scalable, highly fault tolerant, event driven. It's not. It could support any triggering of these pipelines from anywhere, from your microservices, from the applications. Some limitations according to comparing to Airflow, which is just less sophisticated in terms of DAG management, and it's managed by Amazon, so it's good and it's not good at the same time. So it's not possible to test it on your local machine. There are some workarounds, but it's in general, this is the code to be run on Amazon. And it's like so-called JSON programming. You basically define this step functions in a JSON, and like debugging, saving, and basically writing a JSON is not as like programmer friendly as writing a Python code, for example, because it's just a data format. As we move along, so just a few recommendations. If you build a batch data pipeline, please take care about a system layer that will take care about versioning, about contracts from like one stage to another stage, about like unified naming of your folder structure in your S3 buckets. It will take care about transactions and state persistence. What if your particular data transformation task has failed? What you're going to do? Do you want to process it again? Do you reprocess? Do you want to clean up the previous unsafe state and whatever? Some operations friendly stuff like metrics logging and tracing should be considered in a system layer of your batch system, in your batch pipeline. And as a trick, you could build your system layer the way it will allow you to easily switch from batch to streaming anytime. So it sounds a little bit advanced, so I will skip it. So also just tip and recommendation, I suppose, if you haven't heard about Amazon Step Functions, you probably haven't heard about Amazon Glue. So in my that crazy architecture diagram, you've probably seen Amazon Glue there. So it's a must-have service to be used if you are trying to build a data warehouse, data lake on Amazon S3. So all the files, all the data you will have here needs to have a metadata to be extracted, and to use it properly in your SQL queries, in your applications, and your dashboards and visualizations. So just remember, when you start building a data lake, go to Amazon Glue, use catalog, and you're fine. And ETL jobs, if you are considering using Spark, those like Amazon Glue provides that system layer that I have mentioned before, not like on 100%, maybe on like 60% of the requirements I have mentioned here for the system layer for of the pipelines built on Apache Spark. So this is like very brief about the platform stuff. I will give the word to Rinat, who will cover machine learning on AWS. I apologize, we have to share the mic, so bear with us once we are handing it off.
Thank you. Sorry for the delay. So, as Stefan said, now we will switch to AWS services that allow us to build and train machine learning models, or at least to facilitate that process. And AWS has two groups of services. One of them is application services, which means that you can use them. They are ready-to-use tools to process text, speech, image, video, and all internals are managed by AWS. These are services like Amazon Comprehend, Lex, Poly, Transcribe, Translate, Recognition, and they are out of scope of current presentation because we will focus on platform services that allow us to build our own models using our own data to solve specific tasks. So we will start from the simplest one. It's called Amazon Machine Learning, and it's quite ambiguous, not quite confusing name, but it stands for the dedicated tool. It's simplest one, and it doesn't mean that it's bad, and it perfectly fits its own use cases. First, when you are a beginner, and because it provides you ability, to make a regression or classification model without any code, and it has quite good documentation covering all basic concepts and best practices. And second use case, when you know what you're doing and you are lazy, so you can quickly establish some baselines using wizard-like user interface. And to make this baseline stronger, AML provides you plenty of functions like some descriptive statistics over your data attributes. Okay. So functions like inferring descriptive statistics over your data attributes, computing correlations between them, and then suggesting some default recipes for future engineering. And if you want to try, your own transformation pipeline, you can do it just by JSON programming. And it also provides, quite good and interactive visualization over evaluation results. Of course, it's possible to do all of this in your own notebook, but at least it will allow you to play with much more amounts of data, and when using your laptop, and it's will save you considerable amount of time. It has disadvantages, of course. So the first, that so far it doesn't support hyperparameter tuning, even though there are no many parameters to tune in. I mean, linear or logistic regression, mainly regularization coefficients. But anyway, it would be nice to have. And I mean, second thing is cross-validation. It's usually, I mean, very easy to do in frameworks like scikit-learn, and it usually helps you to discover some biases or, I mean, insufficiency of your data set. And of course, it has its own implementation limits, like mentioned here, like max 100 classes or 10,000 output features. Output means after transformation, which might be not good for like cases like text classification, because usually after feature engineering, each word represents its own feature. So
If I don't mind, I'm just going to give you a mic here to make it a little bit easier for people in the back. So as long as you don't mind,
okay,
you can hold this in your hand like this here.
okay.
And so let's just make sure we don't get much feedback. But can you hear me in the back of the room like this? Oh, looks like I woke everybody up. Oh.
Okay, thank you. So this is it with AML, and now we will switch to next section and devoted to Amazon's SageMaker, which is a platform, and it consists of following parts. It has ready-to-use model implementations. It has separate model tuner, notebook hosting, and model hosting. And SageMaker doesn't force you to use all of them or nothing. You can, for example, bring your own model and then reuse its model tuner and its hosting capabilities. And it doesn't force you to use, I mean, SageMaker notebooks to launch all of these. And for example, you can train built-in model on your data and then use resulting model artifacts elsewhere in most cases. So basically, I'm trying to say that there is no, I mean, vendor lock-in to the entire platform. So here is a list of available models so far. So if you end up framing your business problem as one of those in this project, it's probably worth a try. But if it doesn't, you can always bring your own model here, your own algorithm. I think we don't have time, I mean, to cover all of this. I will just mention a few. So, for example, blazing text it's a highly optimized fast text implementations, and it has two different modes. One of those is unsupervised, when you can train word vectors, so-called embeddings. And the second mode is supervised, I mean, just to perform text classification. And training word embeddings is a big deal because most of the neural networks that process text usually takes as input some dense representations of these words. And the good practice is to pre-train them on large amounts of your text, and it's not required to label them. So blazing text solve this problem for you. And one more example is image classification. So as the name indicates, it allows you to train quickly image classification model. And the good thing that it supports transfer learning. It means that you do not have to retrain entire giant neural network from scratch, which can take like days. You can start from a model pre-trained on ImageNet, and ImageNet is like 14 million images pre-annotated, pre-classified. And it also has other handy features. included, like you can enable automatic image resizing if you don't want to mess with it, and enable some data augmentation. So regarding implementing your own model and using SageMaker, there are at least two options. The first one, if you use any popular framework like TensorFlow, MXNet, PyTorch, or Spark, you can try to wrap it into so-called SageMaker estimator. And here is an example how you can do that with TensorFlow. So basically, SageMaker provides a contract to your main script. So SageMaker expects at least 4 functions there, like, and it's quite interpretive. Like one of them, what SageMaker should run to build your model, and then what SageMaker should invoke to connect training or evaluation data, and for inference, how SageMaker, what function should it invoke to connect, raw request data for inference. And the other option is, you can always bring your own Docker image and do whatever you want to it, and to run it, to perform training jobs or use hosting capabilities, your Docker container should comply with these contracts. So here's just a summary of, good things from SageMaker. SageMaker provides you, unified and generic input-output system for training and inference, and since that year, it also supports so-called pipe mode, because before this feature, SageMaker has to copy all your data from S3 buckets to instances, which performed training, and it was quite ineffective. But by this pipe mode allows streaming data directly to training scripts, and also it has model agnostic hyperparameter tuner. It means that you can use it with your own model, and distributed training, and also it's quite cost effective. If you compare it with running, using dedicated EC2 instances for your training jobs, and all of these features are available for your own model. And the bad side currently is that everything in SageMaker, all dealing with data is centered around S3 buckets, and it's sometimes it complicates things, like if you want to train not only your model, but all you have parameterizable feature extraction pipeline before, it makes things more difficult. And in such cases, you can easily, not easily, usually just try to write all these things from scratch. And for those cases, AWS provide you ready-to-use AMI. So it's like instance images with all frameworks and other things like CUDA and and so installed and optimized it. So you wouldn't worry about like some version incompatibility and so on. And regarding notebook hosting, if we compare it to like local hosting of just Jupyter notebooks in your own laptops, SageMaker notebooks provide you, of course, some means to collaborate, and it has better authentication and ready-to-go environment, so you don't have to install all, dependencies on all your packages required to run your scripts from scratch. It also provides you ready-to-use recipes for access management, and there are quite a few notebooks for every built-in algorithms which you can use as a template to start from. And now I will give a word to Iskander, who will talk about notebooks more.
Excuse us. Hi everyone, my name is Iskander. I'm only get of you just a couple of minutes of time. I'm gonna quickly talk about notebooks. All of you are using notebooks, right? It's not an Airflow or something like a strange Dex scheduler or so on. So there are 3 points I want to address in this speech. There are versioning, reproducibility of notebooks, and collaboration. So for the versioning, so you're a data scientist, any software engineer, you have to stick with the good practices. So you have to version everything that you build in a good way. But by a good way, I mean stick to the Git flow. So name the branches in according way, like stick to the merging policies and so on. And also write like meaningful comment messages to your commits. Because in a half of a year, when you get back to your notebook, you will like spend eternity to figure out what is going on what I worked on, and so on. So how to do this? You can go straight to the face and use Git CLI or built-in plugins to Jupyter notebooks or whatever notebook you use. And yeah, one useful trick for me, at least, is to use post-save hooks. So I don't save all the notebooks to my GitHub repository. I only fetch information from the paragraphs and save them alongside with the notebook. So I commit only raw Python code without anything. Yeah. So next, reproducibility of the notebooks. So in a far galaxy, there is like a great world when you don't have this issue, because your DevOps team get rid of that. They manage all of your dependencies, environment variables, and everything. But really, in practice, no one's do this, because to add another dependency, you have to fire a ticket in Jira, like wait a couple of weeks. They deploy, then you run, then you continue to run your experiments and so on. So I'm going to share with you like a hacky way how to. It's not a bad practice, best practice. It's a bad practice actually, and all of your DevOps team will argue on that, but this is the way how to reproduce your notebooks. This is like a 6th step you have to maintain in any of your notebooks to make it reproducible to anyone. So just configure variables, install dependencies, list all the dependencies, define the constants, load data, and print the schema of your data. So it has like all the information that any developer needs to continue working on your notebook. Yeah, and also leverage the possibility of rendering markdown text within notebooks, like commit everything, write a full description to any code you wrote. And the last thing is the collaboration. Here is the 2 architectures, how the companies deploy their notebooks. Like the left one, SageMaker and Jupyter Hub do this. They launch, they encapsulate notebook, kernels, dependencies, and everything within the instance, deploy it. And when you reach to the web interface, they go through the proxy, authenticate you, do everything, and you reach your endpoint. This is the good way you can share your notebooks by providing, by giving access to someone, or you can share it by like committing to GitHub and share the link to GitHub and so on. But there are some cases when you need to like share your notebooks and experience not only with the other data science members, but with management and higher management team, for example. And you want to give them access to your notebooks, but you don't want them to like run it on or change something. This is the right one is the other architecture that Colab and Google Colab and Zeppelin uses. They use multi-user instances. They have a special access controls for each notebook. You can give access right to the group of people to read and write each of notebook. Yeah, so it is like a more flexible way. And there is also extra point. There is a myth that you can deploy notebooks straight to production, but more on that will help Stefan. Thank you.
Okay, so please don't try to deploy notebooks to production. This is not the right way. So there are a lot of like talks and articles about that. How can I deploy the notebooks? And actually, we saw many times how the like 3,000 rows in notebooks are being deployed to production. So it's not the right way. Just decouple your experimentation codes and scripting with the actual modules, and you will write in Python, and just follow the regular best engineering practices here. Deployment. A couple of words about SageMaker capabilities. It's quick and easy, one-click deployment. It supports single row real-time scoring. So it basically have once you deploy, you have a microservice with an API. You send the data, you get the prediction back. Very easy, straightforward. Also, you could configure your batch job to take a batch of your data and score one by one with that API. It has some capabilities for A/B testing, traffic split between different model variants, and of course, auto-scaling group from like must-have feature from Amazon. Some like nice to haves and maybe future improvements in deployment space. Currently, it's although it's based on Docker, but in a nutshell, it deploys Docker on a Docker per EC2 instance. So EC2 instance per module. So if you have like 100 small models to be deployed on your dev QA environments and whatever, you will still need to provision like 100 of EC2 instances. It might be not so elastic as it might be. Yeah. So no contracts. Contracts mean, okay, you have a model, it exposes some API. As a web developer, how would I know what should I pass to this API and what answer for me to expect? Just defining this because most of the models, what they expose is just a feature vector, like array of array, or just a plain array. And for your client, for the web developer, it's not obvious what order in what order should I pass my features in, and what's a shape, what's a format of those parameters. It's very useful to replay when you deploy the model in your staging environments. It's very useful to replay the previous predictions, the predictions you had from the previous version of your model, and compare those models side by side. So it's a little bit more advanced feature, but when you run it at scale, it's like very useful. No model-specific metrics, so it monitors the latency, the throughput, some system metrics, but there are no measure. You couldn't monitor your like accuracy or precision recall, for example, the model performance metrics. Alternative, you can do it yourself, just building a Docker container and deploying it on EKS or ECS. It's not a big deal for those of you who is familiar with this. And yeah, we have a side project. It's an open source project called Hydrosphere.io. It's also dedicated for deployment and monitoring of machine learning models. So as a best practice here, what basically, when you deploy a model, it doesn't mean you deploy just your binary file. For the model itself, it means it's much more than just a model. So it has its versions, it has a metadata, and the most important thing is has a snapshot, a statistical snapshot of the training data that the model has been trained with, because the model and training data is kind of this one single thing. And in order to, the same way you version the model, the same way you have to version the data that has been used for the model to train with. Because if you will trace back and you would want to compare different model versions, it's very useful to have an insight what the data has been used. And later for monitoring the other advanced things like concept drift and model performance, it's also a big deal. So once you get to production, so maybe the last mile, but maybe the last thing to consider is model maintenance. Actually, the machine learning pipelines and machine learning workflows is such a complicated thing that it actually may break everywhere. Yep, it might have just because of bad training data, bad serving data, training serving data skew, misconfiguration, the concept drift that your user behavior is being changed over time, and you can catch this as well. It might experience some adversarial inputs or just upstream errors because the data pipeline has been broken and somebody started sending you zeros instead of feature vector you expect. For the model maintenance, the best practices we can share is to use data contracts between every stage in your pipeline and as well as in a training pipeline and a serving pipeline. By contracts, I mean protobuf contracts or Avro contracts that describes the types of the data you expect as an input and as an output of every stage. Use data profiling. Basically, you should constantly profile the data that comes to the system, to the model, and see if there is a misalignment between training data sets and production data sets. Because as you probably know, it's very known fact, your model is as good as your data. If your data if your production data is different from the training data, you're in trouble. And then the maintenance means, okay, we collect new data sets, we do online profiling, and in order to train a new model, we have to subsample a new data set from the new production traffic we have just received. So having a subsampling mechanism is key for closing the loop between training and retraining. Yeah, and of course some references to you to the for maybe to separate discovery for active training, active learning workflows. When you have a supervised workflow, you discovered a new data in production, you have to label it, put a human in the loop, just and retrain with the new data to improve the quality of your model. This is the very schematic high-level architecture that we usually use for this maintenance life cycle for the machine learning model. So you deploy the model, we monitor inputs and outputs, we do a profiling on the fly, we learn the probability distribution of your new production data, and we constantly compare your snapshots of your production data, metadata from the production with the metadata from the training, and make a decision out of it. Either we need to retrain your model, and if we need to retrain, what data should we use to do that? And then once we know the probability distribution of your production data, you can generate diverse and clean data set for the next retraining batch in your life cycle. So the techniques like stratified sampling might help you to do that, because if you have the whole variety of imagine for example the video stream from self-driving car. How would you do a subsampling? How would you subsample the data for you to retrain? Do you just do a random sample by index of the image? It wouldn't be representative. So what does it mean for you? It's 124 and 145 image number of 124 and 145. It doesn't mean anything. You need to just a really diverse data set for retraining with cars, pedestrians, and all other things you can see on the road here. So those steps training, data preparation, training, evaluation, deployment, subsampling, redeployment, and over again should be orchestrated somehow. Those are the steps to be automated. So what options do we have? We have a classical and old and nice Jenkins. Probably you all know about this. As I mentioned before, AWS code pipeline, also a very generic way to define a workflow. We have a Kubeflow. Do you guys know the difference between Kubeflow and MLflow? Have you heard about this? Basically, very similar names, but in fact, it's very different products. Kubeflow, it's an open source Kubernetes native machine learning workflow orchestration, and MLflow actually it's an open source project, but from Databricks. The main feature that they have right now, and so if you will double click into the all the landing pages, it's experiments tracking. Basically, every experiments that you can run, you can log your results and log your parameters to somewhere to be analyzed, to be not analyzed, to be just aggregated in that nice view. So we have a couple of experiments run with different parameters, and those are metrics you have exposed. So it's a useful feature, and They do have other features, but it's like in my opinion, it's the main one. But what is a Kubeflow? Kubeflow is basically an Argo. Argo is a Kubernetes native workflow manager. It's the way to define this kind of, it's image has been taken from the Argo website. The way to define also a workflow. We go through the maybe to the fifth or sixth workflow engines during this presentation. So you define this workflow. It's absolutely agnostic to any use case. It could be done for CI, for CD purposes, and as well as for machine learning lifecycle workflow. So it's a set of Kubernetes configs for different components like Jupyter Notebook, like TensorFlow, TensorFlow itself, like TensorFlow serving and other components, and just a machine learning tutorial. So it's not Kubeflow, in my opinion, it's not like a tool, it's not a product, it's more like a tool set for you to go through and maybe use it as an example, as a template. I would finish on this slide and a couple of takeaways just to repeat ourselves. So well-architectured data platform is a key to enable there is a misprint, sorry. It's a key for successful machine learning project. Amazon Web Services ecosystem is a great foundation of your enterprise-wide ML platform, but you should know your options. Even within Amazon, it's like a whole universe. You should navigate properly and use the right tool for the right things. And Amazon gives you building blocks, and anytime you should tailor them for yourself and build an extra layer which is like suitable for your use cases, your organization. And machine learning reproducibility and the lifecycle management is very hot and interesting topics right now, but the space is so wild and there is no off-the-shelf solution. Probably we will see it in the future, but nowadays you should consider something to build yourself. Thank you so much. That's it. I'm happy to take questions. Do we have questions on this? Oh, so.
You had a picture of Rocky Balboa versus a green vegetable.
Yeah.
Kubeflow versus Kubeflow.
Yeah.
What was your point there? They're really different, but
that was. So the difference between Kubeflow. Yeah, the difference. Yeah.
What's the green dog?
Yeah. My point was it. I'm sorry, it's not switching. It was a joke, basically. What I mean, it has a very similar names, and but actually it's a different things.
It looks, big familiar with the movie Rocky. It seemed like the slide meant like Kubeflow is better than TensorFlow, but is that it at all?
No. I'm not saying that Kubeflow is better than MLflow. They are not comparable.
It's different.
It's just different, yeah.
Do you like both tools?
Sorry?
Do you like using both tools?
So both tools on a very, very early stages right now. As I mentioned, it's a pretty wild space. They just have some vision. They have some like a documentation. They like want to chart a territory. Or we want to take this, we want to take that. But if you double click, it's not production ready. Just you can watch them out, but it's good to follow them and to see where they're heading to. But yeah, they.
Preference on either of them?
No, it's not about preferences. Yeah.
Or is it one higher quality than another?
Sorry, Paul.
Is one higher quality?
As I mentioned, they are not comparable. So I can't say what is the higher quality. So while one of the Kubeflow is driven by Google, MLflow by Databricks. So both of them just tend to make you running these workflows on Databricks cloud or in Google cloud. So it's you can see this very well, but of course they bring a very new, interesting. They're trying to solve interesting problems. Kubeflow of orchestrating the machine learning workflow, MLflow for tracing and reproducibility of machine learning experiments. So they might overlap in some way. For example, by providing a capability for the hosting as Jupyter notebooks. It's like so there is like SageMaker, there is Kubeflow, there is MLflow. They seem to copy some features from each other, but for MLflow and Kubeflow, I don't see right now a consistent like view. Yeah.
How do you navigate working within the Amazon ecosystem and the Google ecosystem? I noticed you use TensorFlow. What's your experience with that in terms of developing machine learning? There are all kinds of opportunities, with voice on both sides that these would be the basis for.
Okay, what is just repeating question for maybe for recording? Yeah. How do we navigate between Google products and Amazon products when we develop our projects? So for us, customer need is like the first priority. So we first of all we try to solve the customer need and then to come up with a solution. Just historically, where like 99% of our customers are on Amazon, so I don't have like a deep knowledge about the Google project. But TensorFlow is not it's open source. You can major TensorFlow workloads are on Amazon nowadays. So of course, like it may seem that Google Cloud is more natural way to run TensorFlow workloads, but it's not the case. I think, yeah. So that's even Kubernetes, for example, it's being commoditized. It's so Azure has a built-in Kubernetes managed Kubernetes service, EKS, Google Cloud. So everybody is like has the similar capabilities, less or of course. I would say that EKS service has a lot of nice to have features, from my opinion, but it's not a showstopper. Okay, let's wrap it up. I would be happy to chat and hang out here for quite a while.
Thank you.
Thank you so much.